Welcome to this Foster film. You know, you don't improve in mathematics by chance. You only improve in mathematics by choice. Thank you for choosing to be here with us. We hope we can help you today. So you've mastered the art of finding missing side lengths using sine, cosine, and tangent. You know SOHCAHTOA. You know how to find the opposite, adjacent, and hypotenuse sides of a right triangle. But you're a little perplexed about finding an angle measure that's not given. And you're asked to find that missing angle measure not by yanking out your protractor and measuring it. Of course, you know there's a danger in diagrams in geometry. You're not permitted to do that. We've got to use trigonometry, sine, cosine, and tangent tools in order to find that missing angle measure. So let me give you a little introduction here first. I am going to challenge you to solve this very simple algebraic equation in 3 different ways. I'm going to give you a very, very simple algebraic equation, which is 3x equals 12, and ask you the question, all right, Chachi, how are you going to solve this thing? Well, I would. That's right, divide both sides by 3. That's definitely one way to attack this problem. Divide both sides by 3. When you do that, the 3 divided by the 3 on the left-hand side is a 1, and 1 times x is x. And then you do the division on the right-hand side, you get x equals 4. All right, that's one method. What if I gave you the exact same problem again and said, give me another method to solve this? Some of you might suggest, well, how about instead of dividing both sides by 3, we multiply both sides by 1/3? This is going to work also. We can multiply both sides of the equal sign by 1/3. Multiply the left by 1/3, multiply the right by 1/3. Well, 1/3 of 3 is going to give us 1, and 1 times x is x. And 1/3 of 12 is equal to 4. We get the same answer using 2 different methods. The real challenge here is, can you come up with a third method to solve for x? And in fact, this is the most important method with regard to leading us to an understanding of finding missing angle measures in right triangles. Let's do this quickly. I have the same exact equation, 3x equals 12. This time, I'm going to multiply both sides by 3's inverse, the inverse of 3. I'm going to multiply both sides by 3 inverse. You know what that inverse button looks like on your calculator? That x to the negative first power. See if you can't locate that on your calculator. It's going to be a very important button to understand later in mathematics, and it's going to have a lot to do with what we're going to do here in a moment. But look at this. I multiply both sides by the inverse of 3. Well, if you take your calculator and you go 3 inverse times 3, that's just going to give you 1, and 1 times x is x. If you go 12 times 3's inverse, you're going to get 4. So 3 different ways to solve the very simple equation 3x equals 12, but what I want you to focus upon is the third method, multiplying both sides by 3 inverse. What on earth does that have to do with finding a missing angle measure in a right triangle? Let's figure that out right now. Here's example 1. I've got a right triangle, MON. I've got 2 side lengths. NO is 5 and MN is 15. My task is to find the measure of angle M. Well, the first thing to do is look at the information you are given and determine whether the side lengths offered are opposite sides, adjacent sides, or hypotenuse. Well, 7 I recognize as the opposite side to angle M. Again, I'm focusing on angle M. 7 is the opposite side to angle M, while 15 is the hypotenuse. And which one uses opposite and hypotenuse, sine, cosine, or tangent? You've done enough of these problems. You know now that the sine is defined as the opposite over the hypotenuse. So I'm going to write the equation, the sine of angle M equals The opposite side, 7, over the hypotenuse, 15. Now you see here, different than other problems you've done, you've got to solve for that angle measure. You've got to solve for angle M. So I would ask you this question based on what you've seen so far. What do you need to do to both sides of the equal sign to get M by itself? Some of you might say, well, you got to divide both sides by sine. You know, that's not really realistic. It won't work because this is the sine of angle M. That's a composition. I can't isolate M by dividing by sine. I always have to take the sine of something. My best option here, my only option here, is to multiply both sides by the inverse sine. Can you find that on your calculator? Sine to the negative first power. You'll have to hit your second button to access sine inverse. It looks like this. To get M by itself, take the inverse sine of both sides. Sine inverse of the sine of M equals sine inverse of 7 over 15. What's going to happen on the left-hand side? You can probably see with your mind's eye exactly what I'm going to do here. Sine inverse of sine of M. Just a quick note, make sure you are in degree mode or you will not kick out the same answers I'm about to show you. So inverse sine of the sine of M, the inverse sine and the sine kind of undo each other. This leaves you with the angle M. So now, my only contemplation is to take the inverse sine of 7 over 15. I do that on my calculator and I get an angle measure of about 28 degrees. I've found angle M using inverse sine. Let's take a look at another example. So as you go and do additional examples here, whether you're using sine, cosine, or tangent, the crux of the challenge is to undo the sine, cosine, or tangent that you have chosen by utilizing inverse sine, inverse cosine, or inverse tangent. That'll bring you to the promised land. Hope this has been helpful. This is Foster Film, signing out. Have a great day. Over and out.